The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. It is 1 o'clock on the East Coast. This is David Forrest, the General Manager for Collaborative Gains Councils. Welcome to our webinar, What is Data Science Really? It is, we're joined by Q McCallum, who is our Data Science Moderator. Q, how are you today?
So far, so good. David, how are you?
Excellent, thank you. And also Brittany Crown, who is our 365 Program Lead. Brittany, how are you?
Doing well. Thanks, David.
Excellent. We've got a great webinar today. It's we've run a couple of these so far. We did a wonderful one with Dave Roger from Spotify on Agile the Spotify Way. Teresa Torres, one of our other moderators from Council 11, also ran a couple webinars on product discovery, which were really well received and just great webinars. And we've had lots of interest in data science and what it means for your organizations, how to implement it well. And so we've been working with Q McCallum, who is our data science moderator, to develop a series of probably 3 different webinars. We're going to start with an introductory webinar, just kind of demystifying a little bit about data science and talking about how to build a great data science organization. And then we'll have subsequent webinars probably after the meetings in October in San Francisco that will dive a little bit deeper and get more involved into data science and how to make it sing within your organization. So I'm going to do a little bit of housekeeping before I turn over the controls to Q. And for those of you who are in GoToWebinar in the control panel, you'll see a little orange arrow. If it is pointing to the left, you'll want to click it so that it points to the right, and will expand your control panel. Everyone in the webinar is muted by default to avoid mass chaos and crazy sounds. You can go full screen on your presentation if you like. And if at any point you'd like to ask a question or raise your hand for a comment or something like that, you can use the little hand icon. We'll be taking questions certainly at the end of this. We want to have a nice conversation in the second part of the hour. Q will present for about 20 or 30 minutes or so, and then we'll have a good conversation. But if you've got a burning question that you really need to get some clarification on something early, by all means, please raise your hand and I'll call on you. When I do call on you, I'll unmute you so you'll be able to speak. If you'd just rather have type your question and have me ask you and relay it to him, I'm happy to do that as well. So welcome everybody. Thank you for joining us today. I'm going to now turn over the keys to the presentation machine to Q, and we'll get officially started here.
Excellent.
Let's see. Change presenter. And let's do that. There we go.
There we go. Okay, so just to confirm, David, can you still hear me?
I can still hear you, and I can see the test pattern on your as your first slide. If anybody in the audience cannot see Q's slide as a test pattern, please just raise your hand and I'll stop him and we'll make sure that everybody is all set.
All right, sounds good. But we're ready to roll then?
We are. Take it away, sir.
All right, excellent. Well, first of all, thank you to David and Brittany and the rest of the folks at Collaborative Gain for putting this together. There's something very amazing about hosting an event in that the people who do it, they make things look so easy and things run so smoothly, but a lot of really hard work goes on the backside of this. So just a huge thanks to David and Brittany and everyone else for making this happen. Also, huge thanks. Quite welcome. You've earned it. Also, a huge thanks to all of you for coming to listen to me speak and see a few slides. For those of you who do not recognize this melodious voice, as David mentioned, my name is Q. I serve as the moderator for the Data Science Council at Collaborative Gain. And you know, just for a very personal note, I found when either getting advice or when I'm listening to a conference talk, I really like to know who is the speaker and, quite frankly, why I should listen. I'm also really interested to know how the speaker is biased because, let's face it, we're all biased in some way. So I guess a little bit about me. I've been in the general technology industry, tech vertical, for about 2 decades now. Seen a lot of things, seen a lot of what works. I've seen a lot of what does not work, for good or ill. Started my career doing technology in finance, specifically in investment banking. So one could argue that I've been doing this whole data thing for quite some time now. And these days, I focus on sharing what I've learned over the years. I do that by working as a consultant, writer, and sometimes speaker. And I focus on the topics mentioned here on screen. Data strategy is about developing a roadmap, your data efforts. Data monetization, it's about earning money with the data you've collected. And data ethics, I mean, that's just a nice way of saying earning money with the data you've collected, but not getting in hot water while doing it. As far as how I am biased, we will definitely cover that. For the sake of time, we'll cover that in line during the talk, and you'll see what I mean when we get there. But first things first, let's talk about why we're here, and in other words, why data science. I suspect there's a mix of people in the crowd today. Some are already familiar with data science and want to learn how to make it happen. We definitely have some content for you. Others might be wondering, what's the big deal? And I think that's a very fair question. If you look around, you can't flip through a business magazine or a newspaper or any of that without seeing some mention of data science. It's been that way for several years now. It's getting a lot of attention because there is, genuinely a lot of value involved. Businesses are able to learn more about themselves and make smarter decisions. They're able to learn more about their business prospects and make decisions around those. They're able to learn more about their existing customers and sometimes turn that information over to their customers, so their customers learn more about themselves. And they're doing this all because they're analyzing data. Which leads us to today's talk. As I said, there is a lot of genuine value in companies doing data science. As you can imagine, for anything that's gotten this much media attention, there's also a lot of smoke and mirrors, a lot of hype. And the hype, it's a problem just because it tends to obscure some of that true value and some of that true decision-making that goes on. So today, I'll walk you through some of the truth, dispel some rumors, and so you can learn, what is data science and how we can really use it. We'll cover some terminology, how to get started, how to avoid some of the easier mistakes, and when you're done, you should be in a better position to navigate this world and point yourself and your business in the right direction. As David mentioned, we're going to cover a few different topics during this talk. You can almost think of this as sort of like a general chemistry course or sampling platter, and that today's webinar, we're going to cover a few different things. The next couple of talks in this series will be a lot more focused, so bear with me as we cover the sampler platter. And let's get rolling. So when people look into data science, there are lots of ways they can get lost. And the first way I've seen people get lost is in the terminology. There's a lot of it can be very confusing. So for a sample, let's take a look at an article related to data science. Now, if you speak French right now, you're fine. If you don't speak French, you're pretty lost. So you can imagine, if you don't speak a lick of French, but you're required to make decisions based on the information in this piece, what are you going to do? This is why learning the terminology is so important if you're going to successfully navigate this space. Let's check out some words. And it might help to throw some dates on here so you can see when these terms first became popular. And, quite frankly, when they first started to appear in job postings and resumes. First up, it's business intelligence. This is the grandfather of all the business data fun. It's probably the most familiar to those of you in the audience because it's just been around so long. And business intelligence at a practical level, you might see things such as lots of reporting. You might like to see breakdowns of your sales by country or state or that sort of thing. Some mild projections, in other words. Hey, based on the last 8 months' activity, are we trending up or down as far as sales, that sort of thing. When you're talking business intelligence, you're usually talking about data that's stored in relational databases, and it's pretty much spreadsheets on steroids. And I mean that in a good way. I genuinely think spreadsheets are very powerful, and they take a lot of heat these days, but they're still quite useful in the business world. Next up is data mining. And data mining is about making sense of the data you have in hand, right? You're looking for patterns in that data. For example, if you are a telco, you have records of calls as they're made, how long they've lasted between which parties. And if you're a retail outlet, you're collecting data across different stores around sales. And so you might be looking to classify that data, right? In other words, can we analyze the data and put it into some sort of predetermined category? You might also be looking for anomaly detection or fraud detection. If you're in the retail space, or even the credit lending space, you might wonder, is this purchase legitimate? So you're looking for purchase patterns as well. In other words, people who buy X also buy Y. And you might use that information to group those items together somehow in a coupon.
So Q, when I travel to Rhode Island to see my family and they decline my credit card from my bank because I've traveled more than 300 miles from my home, is that what you, the most god awful annoying thing in the world? But I understand why they do it. Is that what you mean by fraud detection and using patterns to kind of determine that?
That's exactly it. And I like the way you framed that. In other words, David lives in this particular region of the country, and suddenly his credit card is being used at some location 300 miles away. We're not necessarily saying it's fraud. We're just saying that's outside of the pattern, and therefore the credit card issuer, makes a decision on the fly. Do we block the purchase? Do we lock the card completely? Do we let it go through, but then call David afterwards? I've had all three happen to me. But to your point, David, that's precisely it.
Yep,
when it comes
good.
to fraud detection. Yep. And I guess to wrap up data mining, sometimes data mining is considered a subset of business intelligence. Sometimes it's the other way around. It's a bit fuzzy. Now, those first two terms are grayed out because they're kind of old school, right? So let's talk new school. Big data, that's generally speaking when you have just tons of data and you want to break it down. This is in some ways a larger form of BI when you think about it, right? Because when the term big data first came about, people were running BI style breakdowns, such as sales by state or number of visitors by day to a website. But they were running it on data that didn't neatly fit into the database format, which is neat tables of rows and columns, nor database size. In other words, analyzing this data just required lots of machines working in concert. All of that data would not fit on one machine, which is precisely why log analysis for high volume websites was such a common use case around 2009, 2010. And as far as tools go, if you've seen enough of the tech literature, you may have seen a tool called Hadoop, H-A-D-O-O-P, tossed around. I mean, Hadoop, it's pretty much become synonymous with big data. In other words, if you're using Hadoop to crunch through your data, you probably have quote unquote big data. You're good. Then predictive analytics came along. I mean, as big data settled, people wanted to start making predictions, right? In other words, based on this data we have about the past and the present, can we make some educated guesses about the future? And it kind of feels like data mining. In a way it is. The thing is, when predictive analytics came around, there was just a focus on marketing and advertising. In other words, can we determine who might be interested in this product? And that speaks more to just the fact that at the time, marketing and advertising were already fairly data-driven. And so they just took up the predictive analytics field and they really filled it out, if you will. That's why a couple of years later, data science came around. And this kind of grew out of, maybe alongside predictive analytics. But in some ways, it was just a reflection on a lot of the newer tools being used and being used in a lot of different fields beyond marketing and advertising. So for example, when I was talking to people back in 2009, 2010 about predictive analytics, they were using a lot more commercial tools, the names of which I'm drawing a blank right now. Whereas when people talk about data science, you often hear them talk about tools in terms of the free and open source things. Like you might hear Python or R or Jupyter Notebook kind of thing. Machine learning is all about developing algorithms and mathematical models to analyze data, usually for some sort of prediction. You may have heard terms such as clustering or classification. That's considered a form of machine learning. What's weird about the term machine learning is that it used to be considered a pillar of data science. That was one of the three major pillars of data science a few years ago. As of probably mid to late last year, machine learning seems to have taken on a life of its own. It's being seen as its own distinct area of practice, although not all of us in the field are quite sure where that boundary lies. So just keep that in mind. And last on the list is artificial intelligence. This is a fun one because the term AI really dates back to, I want to say the 60s, maybe even earlier than that. But it recently came back into fashion around 2016 or 2017. I've seen it used as a synonym of data science, machine learning. I've also seen it used to describe some of the higher end data science or machine learning work. These are the sorts of predictive models that really learn on their own, which is sometimes called reinforcement learning. So if you remember, I think it was a couple of years ago when a team called AlphaGo, or a team built a robot called AlphaGo, and it played World Go champion Lee Sedol in the game of Go. That was reinforcement learning. That's machine learning in real time, what this person's doing and reacting. So if you ever hear people talking about training algorithms and bots to play a game or how to navigate a maze, sometimes even self-driving cars, and that's pretty much where AI fits.
Yeah, I was going to ask you that, Q. So let's pause for just a second and a couple of examples. So in the past, when I've heard the terms business intelligence, or in any of the organizations I've been in, we've looked at our log files and we've pulled it all together. And typically, it's for reporting purposes. We're either reporting up to the executive team or to the board, and we're describing what's happened in the past and making some, in many cases, poor attempts to extrapolate based on what's happened in the past, what we believe will happen in the future. And the vast majority of our forecasting in the late 90s and early 2000s was based on backwards looking things, and in some cases that was fine. When I think about all of the other terms that you've got post 2009, what comes to mind for me are predictions and trying to estimate behavior so that we can target our efforts towards future sales. And so, things like Amazon used to do, we called it collaborative filtering at the time, which was just their recommendation engine. People who bought this also liked or bought this. And so therefore you might like this because you bought it as well. And so that was one of the earlier versions of these things that we saw with Amazon. And you mentioned the Go thing or Watson. So what is Watson? Is Watson AI? Is HAL from 2001: A Space Odyssey? Is that AI? What some of the more kind of pop culture examples of this stuff? Where do those things kind of fit into this scheme?
So I guess as far as when you say where do these things, do you mean just the Watson and the AI, or do you mean all of them?
Well, I mean, the larger question for me and maybe for the audience is just, because I think most people have the reporting thing down, like they know how to look at the data they have and understand what behaviors their customers have already engaged in. Are all of the terms that we're looking at now, data science, predictive analytics, machine learning, is that all about trying to understand how people will behave going forward and react quickly to it?
Yeah, I think that's a fair way of putting it. When people talk about, and that's also why that's why I grayed out the BI and data mining versus the other terms, is that BI and data mining, they tend to be older school terms. You can see they date back to the 90s.
Yep.
And usually when people are talking about BI specifically, yeah, like you said, it's a lot of looking backwards, whereas when they talk about predictive analytics or data science, it's in the name, they're looking forward. And that's not to say that one is any more or less valuable than the other. It's just that tends to be their focus. That said, data mining is kind of a weird one. I think I mentioned before that some people consider BI to be a subset of data mining. For some, it's vice versa. When you look at a lot of the techniques that were used in data mining back in the day, everything like you mentioned, collaborative filtering, you mentioned, I think I mentioned clustering and classification and all of that. There are a lot of people who could, rightfully so, argue that all those also fall under data mining. They did back 20 years ago.
Yep.
And some people could then argue that a lot of these other terms we're seeing, predictive analytics, data science, machine learning, and to a certain extent AI, they also fall under the general data mining umbrella, which I actually can't argue with that, because one of the reasons I was so hip to bring up the terminology here and walk through it is because I wanted the audience to see that these terms, what they have in common is that they're all pretty fuzzy, right?
Yeah.
There is no clear, concrete, widely accepted definition. There is no central authority that says, boom, yes, this is data science versus machine learning. And, for good or actually for ill, really, that makes them ideal targets for shady marketing efforts. One other thing I'd love to point out is that when you look at these terms, especially predictive analytics, data science, machine learning, and AI, if you follow them in that order, what you also see is this weird effect you're seeing in the job market, right? What's happened is that over the past several years, we've also seen a number of boot camps spring up. You've seen them for software development, you're seeing them for data science now. And the idea is that you take this course for 12 or so weeks and boom, you're a data scientist. And so what happens is that people who are already in that field before the boot camps came along, they're engaging in a bit of title inflation, if you will. Someone might say, well, I used to do data science, but now that people are coming out of a 12-week data science boot camp, I'm not the same as that crew. I'll call myself machine learning, because machine learning is still associated with more of the upper end of data science, if you will. And now that machine learning is starting to get some legs, if you will, I've seen some people claim that, oh, I don't really do machine learning, I do AI. And in some cases, and some would say rightfully so, but in some cases, they're just trying to make a distinction between, their experience and their knowledge of the higher end aspect of this field versus the entry level people coming in.
Got it. That's helpful. And I think for our audience, as you're working within your organizations in either potential vendors or new hires or your existing teams, it's useful to remember that there's no agreed upon set definition for these things. And when you're evaluating talent or evaluating projects, it's probably good to get into the specifics of what they're really going to be producing for you and what, being on the same page about what you want your outcomes to be, and so that everybody is saying the same things. So let's shift here and talk a little bit about how people build these teams and what they should be doing to get the most out of this for their businesses.
Yeah, absolutely. Thanks, David. So I guess, to sort of wrap up the terminology side of things, I realize that a lot of you are interested in these terms on a technical level. It's great to be curious and just wonder what do these terms mean. But my hunch is that most of you are here because you're interested, to David's point, in using data science for your business. You want to know what this means to build and deploy a data science team in your company so you can improve your company. So if we're going to talk about data science for business, that involves a slightly different vocabulary, but it's one with which you're already familiar, right? Because if the first place people often lose themselves in data science is getting hooked up on the terminology, we've just demonstrated, it's all pretty much the same thing. The second place I see people really getting hung up or getting lost in data science is in failing to connect data science to business need. And it's not always their fault. I mean, I realize there's a lot of hype going on, there's a lot of excitement in the air. And with all of the razzle-dazzle of the marketing hype, sometimes even pressure from other people in the company who have gotten caught up in that same hype, it's easy to start moving before you know where you're going. But if you're going to succeed, you really want to see it from this perspective here, right? You're increasing profits, decreasing losses, opening new avenues of revenue streams, or you're mitigating risk. Which is great because, I mean, I'm guessing that's how all of you already see your decisions as leaders. So I mentioned at the top of the webinar that I am biased. I'm extremely biased and extremely opinionated, as I'm sure any of my fellow moderators will happily let you know if you get me ranting about data in front of I would love to explain that bias right now. So hopefully what I say for the rest of this talk will make a bit more sense. I did say that I started my career in finance, specifically in investment banking. And I didn't realize it at the time, but I was learning a lot about what it meant to run a data-driven business. And one of the key things I learned is that there was one metric on the trading floor: money. Right? It's a great metric because it's absolute. There's no getting around it. Either you're up or you're down. Either you've made money or you lost it. That's it. And that drove a lot of mindset around technology and tooling, because a trading firm doesn't adapt a piece of technology because it's cool. There's always some connection to business purpose, because technology is an enabler, not an end. So to that end, data science in business is above all a tool. And as a tool, you have to evaluate it on how it's going to improve your business. So for the rest of this talk, I will use the term data science just because it's still the most common, but these tips will apply whether you're calling it big data or machine learning or whatever new term the media gives us next week. So if we're going to talk about what is data science and we're looking through this business lens, this is it. And I've even put it in that big, bold, really annoying yellow to really drive this point home. It's just about analyzing data for profit. We can even take the fun out if you want. It's just analyzing data for profit. That's it. Now, it's not completely old hat. I mean, what's new is that you have companies that over the past decade are really new to collecting and analyzing data. When I talk to people about analyzing data for fun and profit, I tend to hold up Wall Street trading and Madison Avenue marketing and advertising as the sort of big names in that field. The first ones to really conquer it and lay a path, if you will, because they've been data driven since day one. What's happening now is that newer firms are entering the fray, and that's partly because thanks to the just plummeting costs of computing power and storage, and the increasing number of activities that are taking place online in some electronic form, it's given a lot of other businesses opportunities to start collecting data. And as we all know, once you start to fill a database with information, someone else wants to come along and turn it into profit. Profit's great. I enjoy profit. I think we all do. But the song remains the same. You're analyzing data for fun and profit, and that breaks down into two main groups. So analyses, that's just what we've talked about thus far in this call. Right? We're talking about churn analysis, or predicting when a customer is likely to default or leave your organization. Fraud detection, we briefly covered that. Sales breakdowns, all of that, right? You're analyzing that data, which means you're taking it in, you're boiling it down into some insight so that you can make some kind of decision. In other words, decide to stop selling or maybe open up new stores in Virginia. Or you get someone else to make a decision. In other words, trying to put the right ad in front of the right person at the right time. That's an analysis. Data products, some of you may have seen this term floating around. You don't see it as much these days, but I still like to use this. A data product, it's really either just your raw data that you're packaging up and selling to other people in its raw form, or you're packaging up some analysis of that data. So for example, I think we've touched briefly on the notion of a recommendation engine, right? You bought these other three things, which means you probably want to buy this fourth thing. That's a data product. Predictions of when your flight will be late or when your bus will arrive. That's a data product as well, because what you're doing is that you're no longer looking at raw data. You're looking at some derivative product of that data. And that way, you can either make a decision for yourself or make a decision for someone else. So now that we can all agree on terminology, because we're really worried about the single concept of analyzing data for profit, let's shift gears a little bit and let's talk about how we get started.
Q, before we do that, I want to pause for a second because I do want to make sure that everybody is on the same page about terms and that there aren't any kind of open questions or confusions about that. So if anyone in the audience has a question that they want to ask now, raise your hand. I'm happy to bring you in for a minute while, and make sure that we're all comfortable with the terminology and, how Q is thinking about analyses versus data products. I'll give that just 10 seconds to see if anybody's got a quick question. If not, we'll continue. All right, so I think we're good so far. Continue, please.
Just for that, I think I will. Okay, so let's talk. So I mentioned this is going to be a bit of a sampler platter, and again, I thank you for bearing with me through that. So we've covered a little bit of terminology, and we're now going to talk about how to get started with data science in your company. So the thing is, I meet a lot of people who are really interested and even eager to use data science, but they don't really know where to start. And what I can say is data science definitely has its rewards, but you have to put in the work and prepare the right conditions. You'll want everything here to maximize your chances of success. And I've seen people try to cut one or two of these just because they're inconvenient. It doesn't really work that way. Let's walk through these for a second. First thing you'll need for a successful data science effort is people, right? Now, if you've been reading the business literature, it seems the only job title they mention is data scientist, which has led a number of people to assume, in their defense, it makes sense if it's all they're seeing, but it's led a lot of people to assume that, oh, if I'm going to be successful with data science, I need to hire a bunch of data scientists, and that's it. And that is the opposite of the truth. You'll need to involve your business leaders. You'll need to involve your product team, your internal software developers, your IT crew, and all of that. And then after that, you'll want to start hiring your data-specific people, such as your data engineers or your data scientists. Next up, and I guess somewhat related to the people I just mentioned, is your technology. A big part of why you'll want your software developers and IT people on board early on is because they're going to be responsible for helping you collect and store that data. Most people wonder, what do you mean my software developers are going to help me collect data? What I mean is that, if you have a team of software devs in-house, you're probably building some form of custom application, a custom website, or something along those lines. And that means you have all sorts of opportunities to put little taps in place to collect data. Or in other words, there might be all sorts of places where data is flowing through those systems, and you're just leaving it on the floor because you're not collecting it. Something as simple as we built this web app so people can shop around the site, okay? Are we tracking who's actually on the site at a given time? Are we logging that? Are we logging what they're putting in their cart? Are we logging when they put something in their cart and when they take it back out? That's where you need your developers so they can actually add that logic into the application so you can store it. And the key thing here is that if you don't have that solid technology infrastructure in place, if you don't have your developers writing code to put data into that infrastructure, you can have the brightest data science minds in the world and they can't help you because they can't get to the data they need. The next one is a fun one just because this is one that's very easy to skip at the beginning until the people do skip it to their detriment. But you're going to want to put some sort of rules and procedures in place. You want to understand what are the boundary conditions of what you want to achieve and how far people can go. And you want to bake those in early. You can't bake these in as an afterthought. And these procedures and rules, that includes what people can do with the data. In other words, data ethics. Are we comfortable with people performing this sort of analysis to lead this sort of decision? You have to think that over. As well as which people are allowed to access the data and how, which is known as data security. And I mean, the timing on this could not have been worse. I know there have been lots of breaches over the past several years, but I think it was late last week, early this week, Equifax announced that they had suffered a data breach. And that's a big deal. In other words, if you're collecting all this data, especially data about other people, you have to keep it under lock and key, because if it gets out, one, that's loss of competitive advantage. Maybe a competitor can get a hold of that data. And two, that means you're losing the trust of the people on whom you've collected this data, which can lead to lost sales, bad PR, and the like. Another key ingredient here, and again, this is one that a lot of people skip. It's what I call mindset. I sometimes say it's about putting the science in data science, right? And when we think about science, it's all about research and development, or R&D. You're being very experimental. It's all about asking questions and attempting to answer them. And part of that mindset is about realizing that not every analysis will yield fruit. Not everything's going to develop into some sweeping business improvement. So you want to prepare yourself to accept that not everything is going to work out as you expect, and also prepare the business and set up your data science team in such a way, that you're not putting all of your eggs into one basket. You're not saying, oh, with this one analysis, we're going to put all of our money into it, and we know business is going to be amazing afterwards. It's not really the case. And patience, I guess, is somewhat related to mindset. It's just a reminder that not everything will happen at once. You have to pace yourself. And all of this really boils down to planning, right? And the core of that planning is what we call a data strategy.
So, hey, Q,
Go for it.
Before we move on to this, I want to pause and emphasize the elements of the last slide, especially for people who are not data scientists themselves or data architects or anybody who lives in that world and kind of understands these things as carnal knowledge. I'm certainly not one of those people, but the whole process of understanding mindset, of rules, data security, things like that, there's a ton of effort that goes into these things. And in my experience, there is a significant lack of patience at the executive level for the people who are trying to execute on these things well. And I think it's probably worth saying to our audience, many of whom may have felt frustration with their data teams, at all of the kind of rigor that needs to go into this. It's so important for you to have the right people on board, for the technology and the data cleaning, the ETL, and just making sure that the data is in the format that it can be usable, that all of the things that you talked about are in place. It just really doesn't work otherwise. And so for folks who have felt frustration with data teams or analytics teams in the past, hopefully this will go a little ways to helping you have some empathy for those folks, because there's so much effort that goes into this to get it right. When it's right, it's brilliant and it's beautiful and it works. But there is quite a bit of behind the scenes stuff that nobody really wants to, I don't want to know how the mechanic fixes my car. I just want it to be fixed and I want it to work well. And that's often the approach that we as executives take towards things like our data teams. And so I just wanted to pause for a minute to reinforce what you were saying, because I do think it's one of the more important parts of this entire presentation, because we're not all in data science, but we're definitely working with teams in our organizations who are very focused on analytics and in data science and predictive, machine learning and so forth. So anyway, I don't want to go on too much about it, but I think this is one of your more important slides and worth reinforcing.
No, awesome. Thank you for bringing that up. And I guess before we move on to the next slide, I will also add to that. I mean, I think there can be a couple of different types of executives here, right? One side are the ones you mentioned where they're a bit frustrated. They feel their data team is moving too slowly, or maybe they wonder, wait a minute, I sent you off on this mission and you came back and said that the answer is, we don't know. What does that really mean? And that can be tough. But there's also the flip side of that. Sometimes you have what I like to call the office champion. Right? This is maybe the CEO, CTO, or someone who was the first person to really bring this notion of data science or analytics into the firm. I guess I should have mentioned that as well as far as the people here. You cannot have a successful data science effort in a company if you don't have someone at the leadership level who both understands what it's all about and firmly believes in it. Because to David's point, not everything's going to work. You're going to have those rough days where someone comes back and says, the answer is, I don't know. And you need someone at the leadership level to say, look, that one analysis didn't work out, but there's all this other potential we have to keep in mind. So let's not scrap a data science effort just because this first one didn't go well, or because this third one didn't pan out as we thought.
Yep.
So I figured, since you mentioned that, David, I'd add that as well.
That's great.
Cool. All right, so moving right along here, let's talk about planning, otherwise known as the data strategy. The data strategy, it's really hang on, sorry, I'm about to lose my phone here. That would be really bad. All right, can you still hear me?
Yes, sir.
All right, excellent. So the data strategy, it's a fancy term for a roadmap. It's really the holy grail of doing data science well. It is also, and you can see a theme here, it's also a step that a lot of companies skip, once again, much to their detriment. Don't worry about writing all this down just now. After the talk, I will send out a couple of links to write-ups I've done on this topic. But what I'd like you to do, especially for those of you who have been taking notes, is just let's put the pen down for a second. Let's close our eyes. Let's just really take a second to absorb what I'm going to cover for the next couple of minutes, because it's extremely important. And I will also say that if you walk away from this talk having heard nothing else from me today, if you hear what I'm going to cover for the next 2 slides, I think you'll be in a very good place. Okay. So what is a data strategy? It is a bridge between your business needs and goals and your data collection and analysis. A data strategy defines your first data project in reasonable detail. In other words, it tries to line up what questions are you trying to answer, and also how will those answers improve your standing. A data strategy identifies the data you will need to collect in order to run the analysis, because sometimes you have questions and you don't have the data, or sometimes you're going to have to go out and buy the data from someone else or find it. With a data strategy, you'll know that up front. The strategy also details the skill sets required of the people to run those analyses and what tools they will need. And in turn, this answers a very important question, which is, do I need to build a full-on data science team as full-time hires that are going to live in this company for forever and ever? Or do I just have a couple of data projects that I can outsource to an outside contracting firm, that sort of thing? And also a data strategy explains how you will prepare your company to set this all in motion and keep it going, right? So that's the what. And you can probably start to see now why it's so important, because when you have this roadmap, right, you, like any other roadmap, it means you know where you're going. You're not just sleeping in the car, stepping on the gas, and then wondering, oh, well, where are we going? You'll actually know. So that's what a data strategy is. It's diagram time. Let's talk about how we actually get one. You can follow the arrows from right to left. And realize this is a bit oversimplified. The actual process of developing a data strategy, it's not like a 10-minute affair. It can take a couple of days at minimum, but bear with me. The first thing you want to do is take a look at your business. What's working well, what's not working well. Because quite frankly, if everything is fine and you don't think things can get any better, you might want to stop here. Second, assuming that things aren't working well, or assuming that there are some things you would like to do, or you start to develop specific use cases. Get some questions down, right? And you'll notice that for these first two steps of developing your data strategy, I haven't mentioned anything about technology. I haven't mentioned anything about data science. This is just about you knowing your business and your business model. Excuse me. Then you get down to your data sources. This is understanding what data sources you have on hand. To the point I made earlier, what sources of data do you have, but maybe you're not collecting that data, and it could be useful to answering those questions that you've developed. You put all those in a blender, and on the other side comes your roadmap or your data strategy. And what comes out of that data strategy then, what it drives, or step one, it drives your project, because you'll understand what it is you'll need to do. And that in turn tells you what tools you'll need, what sort of ethical and security matters to consider. And I know I've mentioned ethics a couple times, but it's definitely something worth thinking about early on, because the PR cost of unethical use of data can be quite painful. And we'll also talk about what policies you need to put in place. And this touches on what we said before about protecting your data, protecting it from leaks or breaches, or that sort of thing. The strategy will also drive your hiring. One common complaint I hear all across the board is that the data science job market is very tough for employers right now. Right? It's a very hot field. The people in this field, they know they can shop around. And what that means is that you want to stack the deck in your favor. When people say that they want to hire a data scientist, that's a good start, but it's sort of like saying they want to speak to a doctor. Right? There are all sorts of different types of doctors. You need to know what hurts on your end, so you know what sort of doctor you need to see. And similarly, with a data strategy in place, you'll understand what specific skills you need for those data-related hires and when you'll want to hire them. And all of that dramatically increases your chances of making a good data science hire quickly and getting in right early. And just as a quick side note, a number of my friends work in this field, and they've told me in a number of off-the-record conversations that they can tell when a company doesn't have a data strategy in place. They can tell when a company is just doing data science for vanity purposes, and they walk. So what that means is that if you haven't developed your data strategy, you're also shooting yourself in the foot as far as your data science hiring, because the people who are coming in to interview with you, they can tell that things aren't going well. And I guess last but not least, the data strategy helps you with your execution. It's the plan that will show you how to set all this in motion, how and when to involve the various groups in the company, and so on. So I guess in short, the process to develop the data strategy is to explore how you're going to use data in your company in ways relevant to your goals, and then line up a list of projects to execute. And the key takeaway is when I meet with a company that's having trouble with their data science efforts, 9 times out of 10, they don't have a plan. They don't have a strategy. They haven't taken this time to plot their journey before getting behind the wheel, and it's really painful.
So this goes back to what we were talking about before, which is you mentioned the need to have senior level executive folks who are bought into, and even if they don't completely understand it, they're ready to believe the data science team. They're ready to support and believe them. Mm-hmm. And so, when your friends are going to these different companies and they don't think they're serious, or they're doing it for vanity purposes, you say, I like that word. There's an old saw from people back in the 50s. Nobody ever got fired for buying IBM. For portfolio managers back in the 50s, if you kind of had to have IBM stock or you were going to be fired, because even if your returns were negative, you were still applauded for having that. And I suspect a lot of companies will believe that they needed that data science strategy, but they don't have any idea how to do it. And so they do it for those vanity purposes to appease a board member or what have you. So I think we've done a good job of sharing with the audience today that how important it is to support the team, be invested in the process. For the folks who get that and who are supportive of it and do want it to succeed within the organizations, what are some of the biggest challenges that they faced in your experience? Where are people failing who really want to do this well and are trying hard to do it well? Where are some of the gaps in their experiences?
Yeah, I would say I guess we can break this down into two main buckets as far as difficulties. When you actually have that office champion who's behind this. The first one, and I realize as a consultant, this is sort of a weird thing for me to say. This is not a plug, but I'm just going to be blunt. One problem I've seen is when you don't have that data science skill either in-house, or you don't have the data science friend or someone you can tap to say, hey, can you really help me with this? Because I've seen a number of well-meaning executives who they're really eager, they're really bullish on the power of data science, but they've never done it before. Yet how do I phrase this? They just want to go ahead and do it without trying to understand the big picture, and quite frankly, without acknowledging that they're new to this, right?
Yep.
So you can imagine that's a pretty big barrier to adoption, because what happens is they haul off, they do things in a way that they think is correct, and it turns out it's not, and you end up with something that isn't necessarily data science for vanity purposes, but it sure looks like it.
Yeah.
Yeah, and I guess the other big bucket would be, again, looking for good wording for this. The other big bucket would be just not getting enough support from their peers on the inside of the organization. In other words, fellow executives who are just looking for that instant win, who are looking for, hey, David, you said this data science thing was going to really help us out, and it's been X number of months and nothing's happened.
Yep.
And that's sort of a different conversation to have when you're trying to explain to your peers, trying to explain to your peers some of the reality of the situation, which is there is no instant on awesome switch, and understanding how to address their concerns about timing without shutting down early. But I think those are the two big ones.
Yeah, and I'll let you continue, but interesting to note that neither of those things are technology or even data related. They're kind of human being and relationship and support and perseverance related.
Oh, no, they absolutely are. And I guess zooming out a bit, and I'm sorry to take us off track for a second, I know we're running low on time. But zooming out a bit, something I see here is on both sides, on both buckets I've described, you see people who don't understand or don't appreciate the full depth of what they're getting into, right? So for the person who refuses, and again, I know talking to the collaborative gain audience, we're all about asking for help, but so this is sort of a foreign concept to us, but there are a lot of people out there who they won't ask for help, and in part it's because they really think it's simpler than it is. I've had people look me dead in the eye and say, well, I have run a successful software development team, therefore I'm qualified to run a successful data science team. And I figure that might be the case, not necessarily so. And on the other side, the people who don't appreciate the depth are the non-believers, are the ones who just figure, well, I read about this in, Pick Your Business magazine here, and they talk about this company that's doing great things with data science. And they don't realize that company may have spent a good couple of years really ramping up and really developing those solid efforts that they're going to talk about in public. So in both cases, it's really just about helping leadership understand that there's a lot more depth to this than the magazines might make you think.
Got it. So we've got about 10 minutes left in the webinar. I know Q's got a couple more slides where he's going to talk about, how to get everybody on board on the team. But if you've got questions, please queue them up, raise your hand, and we'll call on you. If you don't, that's fine as well. But Q, why don't you continue, and then we'll see if we've got questions towards the end.
All right, that sounds good. And I do want to respect everyone's time. So for this next slide, I'll trim it down a bit. So we want to talk about good signs and bad signs. In other words, indicators of good or bad data science efforts. And they say a picture's worth 1,000 words, so I figured these might help. For those who haven't seen these movies, The Italian Job or The Lady Killers, they are both about bank heists. And bank heists, they are very exciting. They require a lot of planning, a lot of practice, a lot of skill and precision timing to pull off. They also require a bit of luck, right? So on our left, we have The Italian Job, great heist movie, planned well, great team, awesome. On the left, we have The Lady Killers, and I don't want to give too much away if you haven't seen it. I just want to point out that this is a heist movie, but it's listed as a comedy. So take that for what you will. I guess without giving anything away, the core tenet is that you have a ringleader who thought he was really smarter than he really was. Hijinks ensue, things do not go well. So that said, let us take just a couple of minutes. We'll quickly run through indicators of a good and bad data science effort. Excuse me. So very quickly, indicators of a data science effort that is on the right track. You have developed your data strategy, you have your roadmap, and you've tied everything to your business goals. You've built real world use cases. Right? You haven't made any data specific hires until that strategy is in place. And you have involved a cast of characters beyond just data scientists. For this next one, I think it was either DJ Patil or maybe it was Hal Varian, who was Google's chief economist at the time. I think he still is. He coined the phrase, data science is the sexiest job of the 21st century. And I like to tell people that you have to also tackle the non-sexy. So if you have a successful data science effort, or one that's going to be one, you've tackled all of the non-sexy. You've taken care of the infrastructure. You've looked into the ethics. You've tackled the security matters first, not as an afterthought. And you're also going to keep it simple, which means you're going to know when good enough is enough. You're going to constantly look at ROI for the business. You're going to maybe dial back on the data science when you need, or dial up when you need, depending on what sort of returns you're seeing or expecting. And you're also going to keep in mind that sometimes these simple solutions, such as, quite frankly, a spreadsheet, a bit of regression, can take you a long way, and that sometimes the high-end data science might hear people talking about neural networks, that sort of thing. Sometimes it's good, sometimes it's not. You're just going to constantly look through that lens. That's things gone well. Let's briefly take a look at things going awry in your data science efforts. One is that you've started by hiring people or buying tools or launching an entire project without first understanding what do you actually want to know. Or you don't have a plan. And I know I keep harping on this, but without that plan, you don't know really where you're going and you're burning money. Another bad sign in a data science effort is that you only see data scientists. You don't see data engineers, you don't see developers, you don't see your product team involved. Another bad sign, and this very closely relates to not having a plan, is what I call data hoarding, right? This is the notion that you know you have some data laying around, or we can collect more data. We're just going to collect all the data we can in the hopes that someday, somehow, someone will dig through this and find gold. Data hoarding is, one, usually a waste of time and effort. And two, it leaves you very vulnerable to a leak or a breach, because heaven forbid people find out that you've been collecting data about them and they didn't know about it, and then it gets out. Like that's just a double whammy for you. It's really bad. Last but not least, really bad sign for data science effort is someone who expects a magic wand or an instant awesome switch. Even if data science can help you, it takes time, it takes planning, it takes, above all, discipline to bear fruit. So I guess those are the big good and bad signs. I guess to wrap this up, when I talk to people about this, I just ask them flat out, do you want to be the Italian job? Do you want to be the lady killers? You have to pick one. And hopefully you pick the one on the left. I think with that, I think we still have just a couple of minutes left. Toss some questions my way. I also realized that in these scenarios that everyone wants to put their question in front of the group. If you would rather reach out to me directly, my email address is on the screen. So David, do we have some questions queued up?
I don't think we've got any questions queued up. If people do have them, raise your hand and we can ask them. I can unmute your mic and feel free to ask you a question. You obviously can. I know people are probably need to scoot and get to their 2 o'clock on the East Coast anyway, and that's fine as well. Please reach out to Q if you've got more questions. Q, this was great for me personally because it clarified some things that I always kind of felt. I'm hoping it did that for the audience as well, especially for folks who are not intimately involved with their data science teams and are trying to understand how they interact well with them. One thing you said on the last slide that I thought was particularly important was just without a data strategy, you are burning money. And that should resonate with executive teams where let's not jump feet first into this thing and hire 30 people. And unless we know, we have a pretty good idea of what sorts of questions we're trying to get answered. We actually have a question from Marie. Marie, I'm going to unmute your mic. Oh,
Unmuted.
Oh, Marie?
There you are.
Hi. No, I don't have a question. I just wanted to say that this was really great. And that was it. It kind of answered some questions for me, and one of the things that I had always thought was I've been using data for a long time to make decisions. Why are people treating it as though it's something new? And you kind of addressed that.
That's great. Thank you, Marie. That's great for saying that.
Thank you.
Thank you.
Yeah, thank you very much. Glad you liked it.
Great. Any other questions for
Also,
Q before we break? Oh, sorry, Q.
I was just going to say, before we go on to the next question, you said something a minute ago about hiring 30 data scientists. Did I ever tell you that story?
No, I would say good luck. Good luck with that. Doing that at once.
Yeah. You know what? Over drinks, I got a story for you. When you said 30, I thought that number was just a bit too precise. I thought I told you the story. Sorry. Anyway, next question, please.
Yep. So I think we're probably out of questions. I do have one more observation that I made while I was listening to you, and I think that in terms of folks who are trying to build these data science teams in their organizations, it's going to be really important for you to have a guide. Part of any organization I've been in, there's always been a gap between the people who really understand the technology well and the people who don't. And there are often challenges as a result of that. So in the middle of those two people, you generally need a good interpreter, just a translator. And so making sure that there's somebody on the product side, somebody who's on the tech side who can speak both languages is super important. You can be that person by gaining a better understanding and empathy for the data science team. Often people who aren't in that world will want to understand, how does this benefit me beyond pure profit? And within your organizations, if you understand data science better and can speak both languages, you get to act as translator between your CEO, who doesn't understand it at all but believes that it's important, and the tech team, who will respect you that much more for having this kind of understanding. So Q, I want to thank you. This has been really great as an introductory webinar to kind of the terminology and what a data science team looks like and why you would put one together and the investment involved. I think we're going to pursue a second one where we dive a little bit deeper into how to, the profit potential for it. And then I know you want to do a third one about the ethics of it all. This Equifax breach is an important moment in time for us on that front. So with that, I think we'll break. Q, thank you again. This has been great. And thank you to everybody who attended today. We will we'll hopefully be able to get something out to the rest of the community that details what we talked about here today. Thank you, Q.
No, and thank you, David, and thank you everyone who was able to attend. Have a good day.
Great. Have a great day, everybody. Take care.